So welcome to the webinar on LED UV booster for packaging coatings and inks, EBECRYL LED 03. I'm your host, Scott Odger, and your presenter today is Joanne Arsenault, who's our Technical Service and Business Development Specialist. So you'll notice that there is a chat box to your left of your screen. This is the way in which you would go ahead and ask questions, and we will take those questions at the end of the webinar. Webinar should take somewhere between 20 and 25 minutes, and with questions, we should be done in less than half an hour. So please see the instructions on the left in the chat box, and that's the place to enter any questions you might have. So with no further ado, we'll hand it over to Joanne and we'll get started.
Mute myself here. Thank you, Scott, and good morning, everybody. We'll move on to the next slide here and just talk a little bit about UV LED in general and what our UV LED booster can do for you. So a lot of people are moving to UV LED these days. It's certainly been a hot topic of conversation at all the conferences that have been held this year. And equipment is being it's on OEM equipment as well as on the retrofits. And this UV LED has a narrow emission spectrum. Typically, the lamps that are used are centered around 395 nanometers, although there are 385 and 405 nanometers that are used as well. And fairly recently, we see a 365 nanometer with lower power than the others, but the power is increasing on that 365 nanometers. All of these emissions are in the UVA part of the UV spectrum, and so you need to choose your photoinitiators that absorb in that UVA range. And there aren't that many available today, so you have a restricted choice. And most of the ones that are available are these through-cure photoinitiators. So they do really well with through-cure, which gives you good adhesion, but they're not so good at surface cure. And that's what we're going to talk about in more detail today. So this lack of surface cure is really about oxygen inhibition at the surface. And our LED booster principle is we want to increase the surface cure by mitigating oxygen inhibition at the surface. And we do that by reacting with the slow propagating peroxyl radicals that are formed through reaction with oxygen. And when we do that reaction, we generate these carbon-based radicals, which are fast propagating radicals. Now, one thing I want to mention is that this LED booster is not a LED transformer, so you can't add the LED booster to a regular UV formulation and expect it to be a UV LED cure formulation. You do need to change the photoinitiator, as we mentioned, so that it absorbs in the proper area. And then you need to add a booster, or you need to worry about the surface cure as well. Most of the chemistries that are used to mitigate oxygen inhibition are well known and have been well documented. These are thiols, amines, or ethers. And for the same equivalency, generally the thiols will be better than the amines, which are then better than the ethers. Allnex does have a couple of thiol-based products, the Optical LED-01 and EBECRYL LED-02. However, these materials were really developed for non-web-based applications, and so they really don't have the speed necessary for printing presses that are used in the graphics area. So that's sort of why we took on this effort to develop a new LED booster that would be appropriate for use in the on web-based applications. When we did this, we did go with aminoacrylate chemistry. The thiol chemistry does have a few challenges, particularly around stability in a formulation, and in some cases, the odor may not be that which is appropriate for use on a press. So we did use the aminoacrylate chemistry, and we already have some amine synergists in allnex, the EBECRYL 7100 and the EBECRYL P115. The P116 is shown on this slide, but that's the European version of the P115. So we decided to use this aminochemistry, and we wanted to increase the reactivity versus the EBECRYL 7100 and P115. So we increased the amine content on the LED03, or the LED booster, and we kept the double bonds. So we have both acrylate double bonds and high amine content. We also made this new booster polymeric so that it would be REACH exempt, and we could use it in low migration systems. The also was designed to be cost effective. So if we move on to the next slide, which is slowly loading here. We'll talk about the value proposition of EBECRYL LED03. And we found that it allows inkjet and flexo presses to achieve their target speeds without losing surface cure. You can also reduce photoinitiator content, thus reducing your costs, the yellowing, because most of these photoinitiators that are appropriate for LED cure do yellow. And since this EBECRYL LED03 is a low migration material, we can reduce the potential for migration as well. And this potential for migration is also reduced because less photoinitiator is used in the formulation. We found improvements in adhesion, gloss, and color strength when we use the EBECRYL LED03 in inks. And since it's used at 5 to 20% levels, it gives the formulators more latitude in formulating. It also is low viscosity and has good rheology, again, allowing more formulation latitude. As mentioned earlier, it is designed for low migration applications. And if you already have existing LED lamps, that maybe some of the lower powers that were the best you could buy a few years ago, maybe you don't need to buy the new higher power LED lamps because this EBECRYL LED03 may allow you to get the fast cure without that higher power lamps. And we'll talk about that a little bit later as well. So next slide. We will talk about the properties of EBECRYL LED03. And we see that this is a two-functional acrylated amine product, so it has two double bonds. As mentioned many times already, it's a low migration structure, and it's also Nestle Swiss compliant. It's low viscosity at 450 centipoise, and that high amine content is shown here. It's 166 milligrams KOH per gram of sample. The material is stenomer-free. The stenomer designation is really a European regulation. It just means that it doesn't have any low molecular weight monomeric type materials that are classified as stenomers. So meeting some of those UPEA regulations. And the color is quite low at 0.5 Gardner. So next we'll look at the use of this EBECRYL LED03 in some different types of applications. The first one being flexo ink. And on this slide we see a formulation for a cyan flexo ink. And this flexo ink will be based on low viscosity 4-functional polyester acrylate, which has good pigment wetting, that being EBECRYL 452. That will be diluted in a blend of neopenyl glycol propoxylate diacrylate, which is called EBECRYL 145 in Europe, as well as PETIA, the pentaerythritol triacrylate. And you can see those percentages on the slide. Our reference formulation will not use EBECRYL LED-03, and then we have 2 formulations that use EBECRYL LED-03 at 5 and 10 parts. We're using the pigment shown on the slide at 20 parts, and our photoinitiator is a 50-50 blend of TPOL and DETX. We use a couple of additives for wetting and dispersing and defoaming, as shown on the slides. So our formulations on these inks are around 800 at 1.1 shear rate, and around 1400 for the materials containing the EBECRYL LED-03. At 2500 shear rate, it's around 400 for the reference, and 600 to 700 for the modifications. We do see a little lower sharpness index on the formulations that contain the LED-03. So the next slide will show the performance of these flexo ink formulations regarding cure speed. And you can see the reference on a normalized reactivity would have a reactivity of 1. With 5 parts of EBECRYL LED-03, it's up to around 3. And at 10 parts, we're 8 to 10-fold increase in reactivity for yellow, cyan, or magenta inks. We also noted when we did this work that the optical density was not affected by the presence of the LED booster. Moving on to the next slide, we'll let Scott Auger come back in and talk about the photoinitiator shortage that we have going on today.
Thanks, Joanne. Yeah, a lot of people are talking about this these days, and I just want to give a little bit of a background. Basically, the first issue you have is there's fewer suppliers today. Whether it was through acquisition by IGM acquiring the photoinitiator line from BASF and also acquiring the Lamberti photoinitiator line, or through the Chinese government actually shutting down some of the photoinitiator plants due to their VOC regulations, which is a major issue because 2/3 of the photoinitiator production is actually coming out of China. We also have a regulatory risk that has come up. It has affected suppliers in terms of the cost to register a new product or even to reach-register a product. About half the photoinitiators requested by EPA were not registered in REACH. A more recent event, the amine synergists EHA and EDB are being labeled as carcinogens. So those synergists are used in litho inks. They're quite effective and they don't impact ink water balance like most synergists. So allnex has been working on a replacement for this, and we actually have a prototype. We also have found that the commonly used alpha aminoketone photoinitiator has been labeled a reprotoxin. The other impact we're seeing, as Joanne was saying, UV LED has become a bigger part of the market, and it's getting bigger as you see most new printers and quite a bit of the printers that are being retrofitted with UV LED, and the photoinitiator of choice seems to be the TPO and the TPOL, which has led in turn that in a raw material shortage has led in turn to a much higher price People are paying as much as triple the price that they used to pay for TPO, and it's in quite short supply, even with some of the largest consumers. You can use aminoacrylates to lower photoinitiator usage, and that includes the product we're talking about today. We have found that the formulators, our customers, have shifted a lot of their development resources over to exploring photoinitiator blends. So I'll hand it back to Joanne to talk a bit more about what we're doing, what can be done with LED03.
All right, thanks, Scott. So this slide, we're going to go back and use that same reference formulation we used earlier when we were talking about increasing cure speed with the flexo inks. And now, instead of looking at increasing cure speed, we're going to look at reducing photoinitiator and maintaining the same cure speed. So again, same reference formulation as before, and that contains 6 parts of the photoinitiator blend. So if we look at the boosted cyan formulation there in the middle, we've added 10 parts of the EBECRYL LED03 and kept the same photoinitiator content, and we see that the reactivity again increased from 1 to 10 as we discussed earlier. But if we reduce that photoinitiator content by 1/3, in the last column there you see, even though we reduce it by 1/3, if we increase the LED03 to 15 parts, we can maintain that reactivity at 10, that relative reactivity. So again, reduce the photoinitiator by 1/3 and increase the LED03 by 5 parts and maintain your reactivity in this flexo ink. The next slide we'll look at doing the same kind of thing with OPVs. So on these OPVs, we're going to look at an epoxy-based OPV. That's EBECRYL 3720, diluted in 40 parts of TMPTA. And we'll further dilute that in TMPEOTA. In the reference formulation, it took 13 parts of TPOL to get a cure speed of 70 feet per minute. If you go to the green column, the highlighted green column, which says EBECRYL LED03 with less PI, by adding 15 parts of EBECRYL LED03 and 1 part of a XKM photoinitiator, this is a modified TPO, at 1 part, we see that we can maintain that cure speed of 70 feet per minute. So we were able to reduce that TPOL concentration from 13 to 5 parts and maintain reactivity. Very good. The one with less, the column that says less PI, that's just showing the reference formulation for the column in green. So we replaced the LED03 with 15 parts of a monomer, and using that same photoinitiator package, we see that the reactivity is less than 15 feet per minute. So by adding that 15 parts of LED03, you can boost that back up to 70 feet per minute. The final 2 columns on this slide, we look at the other amine synergists in allnex's product line, the EBECRYL 7100 and the EBECRYL P115, both at 15 parts. And whereas they do boost the reactivity over the formulation without amine, they are slower than the EBECRYL LED03. So moving on to the next slide then, we'll look at inkjet. And it's slowly loading, so we'll wait a bit here. The inkjet inks, and you'll see that when the slide loads here, the inkjet inks show similar increases in reactivity as flexo inks. So for the inkjet application, we're looking at a yellow ink. The pigment paste is based on our EBECRYL 151. It contains 25 parts pigment. And we take that pigment paste and let it down with EBECRYL 152 photoinitiator package based on TPOL and DETX as shown. And the reference formulation does not use EBECRYL LED 03, and then the modified one has 10 parts of the EBECRYL LED 03. With the formulation without the LED 03, we see curing around 1 meter per minute. With 10 parts of EBECRYL LED 03, we're up to 16 or 20 meters per minute in the CMYK colors. So nice, again, nice improvement in reactivity for inkjet. We see on the next slide, we'll also look at some other properties of inkjet inks, where we see improvements in optical density and gloss, as shown here. So for all 4 colors, optical density increases with the EBECRYL LED 03, showing better pigment wetting, and the 20-degree gloss also increases, which would be indicative of better surface cure. Unfortunately, we also see increases in viscosity with these inkjet inks, which is not a desired property, however. Next, Scott will discuss some feedback that we've received from some of our beta customers.
Thanks, Brad. Yeah. So what we did is we wanted to sample. We actually started out with 3 prototypes, and these sort of responses from our beta test sites are for the LED 03 prototype. In the inkjet area, 3 out of the 4 beta sites got very effective, very positive results using LED 03. In the flexo space, we sampled 5 different beta sites. All 5 beta sites are moving forward with this product. They saw up to a 50% increase in cure speed, and they saw some good adhesion results and some good scratch resistance. Some of the customers were concerned about Tosca, and we'll talk about that on the next slide. But overall, very positive in flexo. On the OPV front, also, we had some good results with the matte OPV, very good performance on press, but we need to get moving on the Tosca front. Overall, it had good performance with less yellowing because you're taking out some of the photoinitiator that's causing the yellowing. On the litho front, we only sampled 1 customer because we didn't feel like this product would work. Being amino-based, it's going to impact on the ink-water balance. But interestingly enough, the other properties look good. So we went on developing, and we have now come up with a prototype for the litho side as well. Next, we're going to talk about the regulatory status. So basically, this is a polymer, so it has reach. We had some trouble with the PMN we submitted in the U.S., but we've resolved that concern, the EPA's concern with release to surface water, and now the program manager is drafting a consent order. So all we're looking for now is the sort of final signature, and then we'll have Tosca. Right now, we're expecting that in weeks, not months. So soon we'll have Tosca. Next slide, please. Oh, I'm sorry, I forgot to mention. In terms of the Canadian registration, we do have a NSN 9, which allows us to import up to 10 tons. And any customer who wants to import can file a match notification and import into Canada. Okay? I'll hand it back to Joanne to sum up.
All right, thanks, Scott. So in summary here, The EBECRYL LED 03 is an additive that boosts the LED UV reactivity and can be used in flexo and inkjet inks as well as OPVs. It's low migration and Nestle Swiss compliant, so it can be used in food packaging applications. We've seen that it can improve gloss and color strength, and one thing we really didn't discuss, but we also see good adhesion with this material to various filmic substrates. It reduces the yellowing and cost caused by excessive photoinitiator need, and it's REACH polymer exempt and soon to get TSCA, as Scott just mentioned. And the usage levels are 5 to 20% depending on what cure speed you're targeting, and this provides formulation latitude over other solutions. So with that, I'd like to thank you for your attention, and we'd be glad to answer any questions you may have.
So what we'll do is I'll start with a question, and then we'll take questions from the chat box. So type in your questions on the left. So the first question I guess Joanne and I had was around the difference between LED 03 and just a normal aminoacrylate.
Yeah, so versus our other amine synergists, which are, again, the EBECRYL 7100 and P115 are competitive materials out on the market. The amino content in this material is quite high. So that allows faster reactivity. So we did see that in one of the slides I presented, that you see faster reactivity versus our other amine synergists. And even with that high amino content, we also maintain the dye functionality, the diacrylate functionality. So meaning that it will react into the backbone, and it is a low migration material as well versus the other aminos. So applicable for food packaging, whereas the EBECRYL 7100 and P115 would not be appropriate for use in food packaging.
So far we just have the one question. Have you measured the tack-free surface cure of LED 03 system against a comparable UV mercury system?
You know, I'm not sure that we've done that yet, but it certainly would mitigate oxygen inhibition in a mercury cure system, just like the other aminoacrylates would. So I anticipate that it would also be faster in mercury versus the EBECRYL 7100 or P115.
Have we taken a look at the different wavelengths you mentioned and the performance of this product?
Yeah, we did. We have looked at 395 nanometers and 365 nanometers, and we see the boost in reactivity with both those wavelengths. And we've looked at different wattage lamps as well. We have 8 watts, 16 watts, and 24 watts, and you see an increase with all versus other aminos or versus no amino. You see an increase with all those different lamps, but the actual cure speed certainly is much faster with the 24 watts versus the 8 watts, for instance.
I don't see any more questions. Give it a few seconds here. So this presentation will be available if you want. You can request the recording. Just send an email to communications@allnex.com. Okay, now we're getting some questions. Pricing question I'll answer directly to you. So anybody who has a pricing question, go ahead and send an email, and we'll email you directly on that, because there's differences in regions and differences in packaging sizes and so on. Can aminoacrylates undergo Michael addition? It's definitely one for you, Joy.
Yeah. So the aminoacrylates that we are selling are all tertiary aminoacrylate, so they no longer can undergo Michael addition. So if you have a primary or secondary aminoacrylate, it certainly could do that. But the LED03 and the EBECRYL 7100 and the P115, they are tertiary and do not undergo Michael addition.
Okay, I really want to thank Joanne for the presentation and thank everybody for participating. As I said, please email us if you have any additional questions or if you want a copy of the recording. Thanks, everyone.